Welcome to CSI Coatesville. As you can see, this is part 3 in a series on fingerprints. Today we're looking at fingerprint recovery at the crime scene. Now, I'd like you to consider this crime on June 15th, 1933. The heir to the fortune of the Theodore Ham Brewing Company was kidnapped on the streets of Minneapolis, Minnesota. The kidnappers left a ransom note demanding $100,000, which is a fortune for that time. This is during the days of Al Capone and organized crime on the streets of Chicago. Kidnapping was a big business at the time. Well, the family paid the ransom and Ham was released near Wyoming, Minnesota. Was this the perfect crime? Well, we'll come back to that. As we look at today's program, we're going to be looking at fingerprints found at the crime scene. How are they recovered? We're going to look at non-destructive methods of recovery as well as some destructive methods of recovery, and you'll see the necessity for those during this program. First, at the crime scene, there are basically 3 kinds of fingerprints that officials find at the crime scene. Those that are visible fingerprints that are easily deposited by blood, paint, or ink that are on the hands and then transferred to another surface. There are also those that are found on soft materials such as putty or cheese. There's also the most common kind, which we find today, are latent fingerprints. These are invisible to the unaided eye, and they're made visible through the use of special lighting techniques, the deposit of powders, or some chemical process. Now, non-destructive recovery. What do we really mean by that? As much as possible, we'd like to preserve the evidence that's found at a crime scene without changing it. However, there are times when it's necessary that something would be deposited on that evidence so that we can recover fingerprints. So, let's take a look at these. First, there are special lighting techniques that can be employed, such as ultraviolet light and infrared light, that are going to make fingerprints visible on certain surfaces. The advantage to these is that no materials are deposited on the physical evidence at the crime scene in any way, and they also work on any surface, so that's a real advantage. There are other types as well that are non-destructive, typically powders, solid powders that adhere to the oils in the perspiration of the fingerprints. The most common type that you'll see are black powders, but there's also white, there's powder that is fluorescent, and there are those that are magnetic, which help out as well. Keep in mind, these work very well on non-porous surfaces. By non-porous here, what I mean is those that are smooth. For example, what you can see here is some glass, a glass container, a dish that has fingerprints on it. So that would be considered a non-porous surface. And then moving on with another type, a very useful type of non-destructive recovery, is something known as iodine fuming. Iodine is a red crystal that can be placed in a container with the artifact. And that crystal will sublimate. I'll write this term here. Sublimation. Now, what is that? Well, it's a term you may recall from chemistry, where a crystal, a solid, is going to convert directly to a gas. So we have a solid going directly to a gas. And as that goes into the gas, inside this chamber, into the air, it's going to deposit itself back as a solid onto the oils that are found in the fingerprint, so it adheres to them. Keep in mind, however, that these are temporary. If you were to look at that, in this case we're looking at a piece of cardstock, it looks like. If you were to come back and take a look at that the following day and that were open to the room air, well, these ridges that you see so nicely identified here, they're going to be gone again, because this iodine is not going to continue to stay binded, adhered to the oils that are in this fingerprint. They'll just go back and sublimate back into the air again. Hence, we call this a non-destructive recovery method. So it's very useful, but once you have the print, you'll need to take a photograph or scan it on a computer scanner and then preserve that print that you have so that you can further process it. This works very well on many surfaces. We use it most often on not non-porous, but porous surfaces, such as paper. Now, the destructive methods. In other words, these are going to form some kind of permanent change on that physical evidence. We want to avoid that where we can. Sometimes, however, it's just not possible. For example, silver nitrate. This reacts chemically to the sodium chloride, the salt, if you remember, in your perspiration. And that will produce a dark gray precipitate of silver chloride on the surface of that material. Again, not non-porous, but porous surfaces such as paper that you can see being sprayed here are what we have in mind. Now, how does this actually happen? Keep in mind, if we have silver nitrate, AgNO3, and we react that with the salt in a person's skin, that is going to convert, and it's a double displacement reaction. We're now going to get silver chloride, which is that gray solid, plus sodium nitrate, which is a white solid, and that just dissolves very easily in water, by the way. Silver chloride, however, would not. So we get a nice solid precipitate here of silver chloride that's deposited, you can see right up here, as a gray solid, and this is on paper, and it's a terrific method. Keep in mind that it is hazardous. Silver nitrate is hazardous, so that's probably not something that we're going to be using in class this year, but it works terrifically. Another destructive method, which we will be using, is Ninhydrin. Now, if you remember, there are amino acids that are found in the perspiration of our fingerprints. Keep in mind, amino acids are what proteins are made of, and the Ninhydrin is going to react chemically to these and produce this nice purple precipitate that you see here. It's going to be relatively faint, so typically that's going to be photographed, and that can be further processed using graphics software, which I have a video on YouTube already on that. Feel free to take a look at that using a program called GIMP, which is free at gimp.org, found on the internet. Now, this works on most surfaces. It's very good for porous materials. However, in the lab, it's got a short shelf life. We typically put this into a solution of a volatile solvent, such as ethyl acetate and acetone, and that will evaporate very quickly. But Ninhydrin breaks down very quickly, so it's got to be refrigerated, and it usually only lasts about a day. You'll notice that the person that's using this in this picture, they have latex gloves on them because, as you know, your skin has protein, and that's going to permanently stain your hands purple. So you really need to protect yourself. It's best if that's done under the fume hood. That's what we'll be doing here. One way to speed up the reaction is to use a hot air gun, which we'll use, or even an electric iron that you have at home. That will work just as well. Okay, and then another very useful method, and this was really kind of found serendipitously, is cyanacrylate, superglue. That's right. It's the main ingredient in superglue, and this is going to adhere to all types of fingerprints, and it's going to produce a white, crusty precipitate, permanently binding itself typically to whatever the physical evidence that you have. We normally perform that in a chamber, and what you'll see done here is we have a hot plate and a little foil cup is made where the superglue is squirted into. That gets warmed up. We also are going to have a cup of water that's placed in that box with the artifact, and the material is going to deposit itself on whatever fingerprints are on artifacts within this box, and the rest of the material is going to just absorb right into the cup of water there, so it doesn't go into the air. We also perform this under the fume hood because that's not something that needs to be inhaled would be hazardous for you. It works terrifically on just about any surface. As a matter of fact, I'm even aware that on fine knit clothing, such as a silk tie, for example, you can actually pick up a fingerprint using cyanacrylate. Even skin on a decedent from another person, you can sometimes pick up a fingerprint on the surface of skin using cyanacrylate. Keep in mind, however, this is a destructive test, so it's going to permanently alter the physical evidence that's there. Now, consider the following. What would be the most appropriate recovery method for the following? Now, the perfect crime. Was it really? Guess what? Was the Ham kidnapper ever identified and brought to justice? You know that Mr. Ham was released after the $100,000 ransom was paid. But did they ever catch the bad guys? Guess what? Silver nitrate solution was used to reveal fingerprints on the actual ransom note, leading to the arrest of these two gentlemen, Karpus and Barker. Well, that's all the time that we have for now. Thanks a lot for